The higher order mapping operators differ in the way that they respond to emissions from the outer observable as they are processing the inner observable. In this demo, I have an input box, various buttons, as well as a display. The input box is the outer or source observable. The display is the inner observable. Each character that I type into the input box is an emission from the source observable. The inner observable takes each emitted character and retrieves some random cities, all of which begin with the character that has been emitted. So as you can see, I typed letter A and got 7 cities that begin with the letter A. I typed the letter B and the inner observable returned 7 cities that begin with the letter B. I typed the letter C and retrieved 7 cities that begin with the letter C. What you're going to see is how using a particular higher order mapping operator will process the retrieval of the cities as I'm typing other characters into the type characters text box. One thing to note about the inner observable is that I've added a random delay to the end of each observable, and that delay can be anywhere from 1 to 4 seconds. Let's clear the display, and first we will explore how the concatMap operator responds to emissions from the source observable. So what I'm going to do is I'm going to first set up the display to use concatMap. And you can see I've clicked the concatMap button and the display shows that it's going to be using the concatMap operator to create and flatten the inner observables. So what I'm going to do is I'm going to enter A, B, C, D, and E into the text box, one after the other, and we'll see how concatMap handles these emissions. So I'll type A, B, C, D, E. So as you can see, concatMap, like any operator that begins with concat, it maintains the order of the emitted values. That is, it processed each inner observable in the same order that the source observable emitted its values. So I entered A, B, C, D, and E, and the cities were retrieved in that very same order. So what I'll do is, again, I will type the letters A, B, C, D, and E into the input box and watch what occurs. So first I'll clear, choose concatMap, and type A, B, C, D, E. And again, we're going to see that concatMap will maintain the order of the source observable's emissions. And it's always going to do this. So that's the way that concatMap responds to the emissions from the source observable. It processes the inner observables while maintaining the order of the source observable's emissions. And here's another thing to note. If the source observable emits in rapid succession lots of emissions, concatMap will always try to maintain the order of those source observable emissions. And this could lead to memory leaks. Now let's take a look at how the mergeMap operator works. I've cleared the input box and I've set up the demo to use the mergeMap operator for the creation and flattening of the inner observables. Into the input box, I'll type the letters F, G, H, I, and J. And notice with the mergeMap operator, the order of the source observable's emissions, the order is not maintained. Instead, what the mergeMap operator does is it handles the emissions in parallel, unlike the concatMap operator, which handles source observable emissions serially. mergeMap does two things. It will process the inner observables in parallel, meaning some of the processes, inner observable processes, are handled at the same time. And also, it will return the return value of the inner observable whenever the inner observable completes. And because it doesn't maintain the order of the source observables emissions the way that concatMap does, and because it processes its inner observables in parallel, mergeMap tends to be the faster of the two. Just so that you can see exactly how mergeMap operates, I'll clear the application and restart the mergeMap process. And again, I will type the letters F, G, H, I, and J. And notice the cities are retrieved in a completely different order. So in your code, when you're considering which of the two to use, mergeMap, because of its speed in returning its values, is typically the one that you want to go with. However, if you need to maintain the order of the source observable, then concatMap is the one that you want to use in your code. One thing to note about mergeMap is that, like concatMap, it can suffer from memory leaks. And that's because both of these operators tries to handle each emission from the source observable. And when the source observable's emissions occur in rapid succession, then both concatMap and mergeMap are susceptible to memory leaks. Now I've cleared the demo and set it up to use the switchMap operator. And I'll type the letters K, L, M, and O into the input box. And let's see what occurs when I type those letters. Notice switchMap has returned only the inner observable for the last emission from the source observable. So that we can see that again, I'll clear the demo, select switchMap, and again, I'll type KLMNO. And again, we see the cities beginning with the letter O. And that's because what switchMap does is, as it's processing an inner observable, if the source observable emits another value, it cancels what it's doing in the inner observable and begins another process using the most recent emission from the source observable. So when I typed K and it began retrieving cities for the letter K, and immediately I typed the letter L, switchMap canceled the retrieval of the cities for the letter K and began working on the cities that begin with the letter L. And that's exactly what occurred until the last letter O was typed. So switchMap has this cancellation functionality, which does filter emissions from the source observable. Now, one thing to note is that switchMap will only cancel a process if it can cancel it. If it's already gone through the process, the inner observable, and retrieve the value from the inner observable, then it won't cancel it. And that usually occurs when the inner observables run very quickly. In this case, remember, I have a delay, which is anywhere from 1 to 4 seconds. So it could easily cancel ongoing inner observable processes in this example. Because of its ability to cancel ongoing inner observable processing, switchMap is much less susceptible to memory leaks than concatMap and mergeMap. But again, memory leaks can happen. However, the cancellation functionality of switchMap makes that a lot less likely. And now let's take a look at our last higher order mapping operator, exhaustMap. And this time I'm going to type the letters P, Q, R, S, and T into the input box. And let's see how exhaustMap handles the source observable's emissions. So exhaustMap returned the cities for the first character that was emitted from the source observable, but it ignored all of the other emissions from the source observable. And that's the way in which exhaustMap handles emissions from its source observable. As it's processing an inner observable, if subsequent emissions from the source observable occur, exhaustMap will ignore those emissions from the source observable until it has completed the processing of the inner observable. So what I'll do is I'll clear the demo. I'll set the demo up for using exhaustMap again. And what I'm going to do this time is I'm going to type the letters P, Q, R, S, and T. I'm going to type them, but I'm going to type them a little bit more slowly. And this time we retrieved the cities beginning with P and the cities beginning with T. And that's because when I typed the letter P, exhaustMap began the inner observable for the letter P. And as I typed Q, R, and S, it was still processing the retrieval of the cities beginning with the letter P. So it ignored Q, R, and S. But by the time that I typed the letter T, it had completed the process of retrieving the cities that begin with the letter P. So it began processing retrieval of the cities beginning with the letter T. And because there were no other emissions from the source observable, it returned the cities beginning with the letter T. exhaustMap has an ignore functionality, which is different from the cancellation functionality in switchMap. switchMap cancels inner observables while exhaustMap cancels source or outer observables. And like switchMap, exhaustMap is less susceptible to memory leaks than concatMap or mergeMap. But the thing to remember when using any higher order mapping operator is that the speed with which these operators receive emissions can, under extreme conditions, that is, rapid emissions from the source observable, any of these operators can be susceptible to memory leaks. And that's why typically in the real world, we don't just rely upon the manner in which the operator handles source observable requests. We also tend to employ things like loading indicators or things that will prevent rapid emissions from the source observable. Now let's begin using these higher order mapping operators in our course application.